the 12th session, which is of pointers. As I said, to take up the concept of call by reference, we need to get the concept of pointers first. So we'll take up what exactly pointers are now. Introduction to pointer. It is nothing but a variable which holds the address of another variable. The basic definition of a pointer is, it is nothing but a variable which holds the address of another variable. So you can treat the pointer is also a variable, as we say, as we used to say, int I. Now we call I as of type variable. Likewise, pointer is also a variable, but it holds the address of another variable. Now what do we mean by address of another variable? The two operators we use in pointers are, we will be taking up two new operators in this concept of pointers, which is the ampersand, we call it as address of operator, and the star, we call it as value at the address operator. So these are the two operators which we are going to use now. Declaring and initializing pointers. Int I is equal to 3, which is the one we have been using till now, the data type, and I is the variable in which we are placing the value 3. The declaration tells the compiler, reserve space in memory to hold the integer value, associate the name I with this memory location, store the value 3 at this location. This is what happens in the compiler's memory when we say int I. We are reserving 2 bytes of space because it is of type integer under the name I, and we are placing the integer value 3 into the variable I. So this is what happens. You are reserving 2 bytes of space whose name is given as I, the location name is referred to I, and the value at that particular location happens to be 3, and the identification of this entire location is unique with the help of the address of that location. So int star j, this says it is a pointer. Now when I say int j, it is a variable which takes integer values. Now this is a pointer variable which take the address of another integer variables. And to place the address of another integer, this is how we'll be saying ampersand I into j, that is j takes the address of I. So this says place the address of I, which happens to be 6485, into the variable, the pointer variable j. And coming to the addresses will not be the same all the time. If it is 6485 here, it can be some other thing for the address of I. It's not sure that all the time I'll be getting the same address for the same variable. Syntax. This is how you need to follow to get the address, ampersand, address of, we call that as address of the variable name. Used to get address of variable in memory. Star variable name, this is a pointer, we call it as value at that address. Operations with pointers. Certain operations are not at all possible with pointers, that is possible and few are not possible. Let us see the possible operators. The following operations can be performed with a pointer. Addition of a number to a pointer, subtraction of a pointer, subtraction of one pointer from another can be performed on a pointer. Do not attempt the following operations on the pointer. Addition of pointers, multiplication of pointer with a constant, division of pointer with a constant. We'll see what exactly all these do and do not things on pointers. As usually, the standard header file, a function, integer I, which takes the variable 3. Now when I say printf %d, I, it's clear that I'll be printing the value 3, what I holds. Now if I say ampersand I, it's not the value of I, it's the address of I, which happens to be 8672 for the variable I. Now saying star ampersand I, that means read it, value at the address of I is 3 again. So you will get the output 3. And pointer is a variable, star p is a variable in which we can place the address of I. Now when I say printf %d, a new line character, comma, printf %d, a new line character, and star ampersand I. Now simply saying p, let us see what it gives. As you can see, the first statement ampersand I is giving 8680, value at that address 3, and again p 8680. Why ampersand I and p are giving the same result? Because the address of I has been given to the pointer variable p. Now wherever I say p, it is equivalent to of ampersand I, that is address of I. Now if I say printf %d, new line character, comma, star p, I'll be getting the value 3 again, because I can replace ampersand I with p. So this ampersand I is p and the star is outside. When this can print 3, why not this prints 3? That is the reason when you say ampersand I into the pointer variable p, you can replace ampersand I with p. As you can see, the address has been changed. Previously it was 8680, now it's 8684. So the address keeps on changing. Now if I print %d, a new line character, comma, ampersand p, what does this say? It says address of p, which is stored nowhere at this stage. It is 8684. So for each and every variable we have, you declare it holds certain address on the compiler's memory, and that address can be given with the help of ampersand operator. Now to store the address of p, what is that I need to use? Is it still pointer p1? If it is star p1, then what is the difference between star p and star p1? This is not possible, because this is a pointer which holds the address, and this is also a pointer which holds the address. So to place the address of a pointer, not a variable this time, to place the address of a variable, I need single pointer. To place the address of a pointer, I need double pointer. Now p1 holds, p1 is quite same as ampersand p. So these two outputs give the same. The last two outputs, ampersand p, it's 8688, which is given to p1, therefore p1 also gives 8688. Now if I say comma star p1, I'll be getting value at the address at p1. What does p1 hold? p1 holds address of p. The value at address of p is ampersand I. So the first statement and last statement will be the same outputs. The first statement ampersand I and the last statement will be the same outputs. Comma double star p1 gives, trace it in this way, p1 holds address of p. A value at the address of p, which is address of I. Value at address of I is nothing but the value 3 again. So the last output gives 3. So likewise, there is no end for me to store, say, the pointers. Address of P1 can be given to triple star P2. Address of P2 can be given to 4 stars P3. Address of P3 can be given to 5 stars P4. So there is absolutely no end for me to say the pointer types. Now coming to the operations with pointers, pointer arithmetic, addition of a number to a pointer, subtraction of a pointer, subtraction of one pointer from another. So this we can see in the concept of arrays and pointers. There will be take up what is addition of a number to a pointer, subtraction of a pointer, and all those things, as well as we'll try to do all these operations which says do not attempt the following, but still we'll try and see what exactly happens when we go for this.